questions for our presenters? Oh, and there are microphones running around somewhere. Here we go.
Hi, Eileen. I'm talking for ZTNet in Singapore. Shall we talk about the need for fair, responsible development, which was interesting. But do you feel that there's a current pushback from the public of tech companies collecting data over concerns of privacy? And with the recent revelation that Google has been collecting location data, even though it's been turned off by the users, do you think that such news making headlines may kind of impede on the development of AI, especially when data is a huge component to feed models and to make it more intelligent? How do you balance that requirement?
Yeah, I mean, I think we've always had a strong tradition of giving users control over their data and allowing them to sort of understand what data that Google has about their usage of our products and how we use that to improve our products. I do think that in a lot of cases, many of the problems that we're tackling don't require human, user-specific data, and actually don't require very large amounts of data. A lot of the improvements here are through algorithmic improvements and sort of computational improvements, not necessarily through massive data sets. And I think, obviously, we want to use user data to improve a lot of our products, to give users sort of control over that data.
Great. I think we have another question in the room here.
Hey, Thomas Lo from Ping West in China. Hey, Jeff. Yeah, just a question about TensorFlow platform. So we just noticed that as a AI or machine learning development platform for TensorFlow, and it's obviously now suffering some kind of the challenges by other platforms like the MXNet or Cafe, Kiss MXNet and Cafe. Now it's obviously getting closer with Amazon. And now in China, Baidu has its own paddle. So how do you think about this kind of the challenge, like some kind of the big organizations or companies are worrying about using Google's TensorFlow to develop more things, rather some kind of small developers are truly welcoming TensorFlow. How do you think about this kind of the challenges for TensorFlow? And another question probably for Vinny Ha is about the translation. Just the language and linguistics is pretty highly culture relevant, and it's really dynamic. People just create different sort of the proverbs or the new phrases and new words, and from time to time through internet and through their daily life. So how this kind of the machine learning or this kind of the translation into the artificial intelligence into translation can catch this kind of the paces of the people's creation of their own language and linguistics to create better and more relevant and more high quality translation. Just sort of like that. Thank you.
Should I tackle the first one? So the first one, I think, there's definitely lots of open source platforms for machine learning out there, and I actually think that's great because they all are slightly different and have different strengths and weaknesses, and I think we can all learn from each other. So TensorFlow is sort of continuously evolving and adding new features that our users really request and that target different kinds of audiences like researchers or people trying to deploy things on mobile platforms or things like that. So I actually think that's a good thing. The TensorFlow open source software actually is released under a really flexible license. It's got an Apache 2.0 license, and that pretty much means anyone can take it and do whatever they want with it. And that actually has been a really good thing. I think that is part of the reason for the success of TensorFlow. People can feel like they can adopt it and actually use it in whatever company they're in, a startup or in a large company. We've got lots of great contributions from other big companies. So Microsoft did some really nice contributions to TensorFlow to get it to work well on Windows, things like that. So we see a pretty healthy ecosystem, and we're learning a lot from other open source platforms and continually improving TensorFlow. I think that's how we continue to make it better.
I can't speak for Translate specifically because I don't work on Translate, but I can talk about it in language in general, right? So I think you touched upon something that's really important and interesting, especially along the lines of what I was talking about with voice, right? We know, for instance, Chinese we talk about it, especially in the West, we talk about Chinese as if it's one language, but we know that this is not the case. Not only because there's a simplified Chinese in mainland China, the traditional Chinese in Taiwan and Hong Kong, but then you also have the spoken variety, right? Mandarin and Cantonese, right? So, and that's just the difference between the spoken language and the written form. And then on top of that, you have, when we were working on actually Cantonese, I was talking about this earlier, Cantonese was actually one of our first bilingual models because we learned right away by looking at the queries and looking at how people actually spoke, there's a lot of English within their daily language and within their vernacular, and we wanted to make sure that we included as much of the English and Cantonese with, and then the written form of Juping, right, and Pinyin in Chinese, right, mainland China. So to be able to pair the written variety and the spoken variety and actually create machine learned models is the tricky part. But one of the things I do know that we have been able to make huge successes with the neural nets model and Google Translate is the volume of data, and to be able to have little sets of really good data that really has improved the models for the Asian languages.
I'll just touch on one more item in your question, which is, I think another part of your question was, when you deploy a machine learning system, how quickly does the data you want to use in the system change? And different kinds of problems have very different paces at which that happens, right? Things related to user queries, for example, change day to day because all of a sudden there's a new chocolate festival in Tokyo and people are querying about it. Things like very low-level speech recognition models don't necessarily change that fast because the sounds people make don't really change day to day at the low level. And things like maps kind of change at the scale of humans opening up new businesses. So it varies a lot by the problem, but it is really important that the way you train your model, the distribution of data needs to reflect the data that you're actually testing it on.
Okay, just going to take one from Taipei, and my phone just locked. So Google has rolled out Pixel Visual Core on imaging. Will you roll out chips on voice input next?
I would say maybe this is for the Pixel phone, or is this about TPUs or?
I think yes, exactly. It's a visual TPU.
So we designed the TPU chip to actually be able to run lots and lots of different kinds of machine learning models. So the chips are not custom to a particular model. They're custom to run the kinds of operations that occur in lots of different kinds of neural nets very quickly. And so, for example, most of the work that you see here are models that run extremely well on TPUs. Things like vision models, speech models, language translation models, various prediction models. All of those take advantage of the core processing capability in those models, which is essentially doing really fast, low precision, high throughput linear algebra.
Great, perfect, thank you. I think there's a question over here.
Peter Marks, ABC. You talked a lot about narrow AI, winning at Go, finding tumors, all great stuff. But the criticism or the warnings that have come from business, from Elon Musk and Bill Gates, they're all about general AI, broad AI, a machine that's really intelligent. Is there any work going on there? Is Google Assistant going to become conscious one day?
Do you want to take the conscious Google Assistant?
So our goal with the Assistant is to make it useful for users. And when we look at doing that, we start with at least running user studies to figure out what are daily information needs that people have. And the Assistant should be helpful, and that should be the primary experience. It's not about mimicking humans or solving this in a general broad sense, but things that we need help with, the Assistant should be helpful in providing help in those instances and making your life easier and better so that you can do those tasks easier.
So what do you think of these warnings, these criticisms? Are you doing anything about it? Are you worried about it yourself? Are you putting in safeguards?
So, I think they're kind of very distant, very far off kinds of fears, and I don't think they're necessarily very realistic. I do think that as we start to deploy more machine learned and AI systems in the real world, where they're actually taking actions that can have serious consequences, there are very concrete and real safety problems in deploying these. Essentially, we now have systems that are learned rather than hand-coded. And that is a very different kind of system. You know, the way we make sure that coded systems are safe is we have a lot of good software engineering practices around testing and making sure that it works well in lots of different scenarios. And I think we can use a lot of those techniques, you know, altered somewhat for deploying safe AI learned systems. And so I think that's the more pressing kind of research to do in the short term. And these long, far off fears don't really seem actionable to me at the moment. Like, I think we're so far from, you know, systems that have those capabilities that it's not sort of the main point of concern right now. We should focus on the more pressing concerns.
Peter Griffin from RNZ, just in a similar sort of vein. Jeff, what, you know, as a leading researcher in this field, what is your ultimate vision for AI in your lifetime? I think there's a perception in the public that what you're all striving for is sort of true human level reasoning. Is it that? Or what is it for you? And what are the barriers you have to overcome technically to get there?
Mm-hmm. So, I mean, I think the question just before this about narrow AI is definitely where we are now. Essentially, the systems we're training are good at one or a handful of things. And ultimately, I think we want to make more flexible systems that can be sort of more useful. That would be good for the assistant so that it can, you know, answer any question you might throw at it rather than sort of a more limited domain of things. Ultimately, I want to build things that really help people achieve more than we could without these kinds of technologies. And I think we have great opportunities to do that in areas like healthcare, in sort of conserving the environment, in self-driving cars are clearly going to be, you know, a big impact on the world. They'll be good for the environment. They'll be good for sort of how we do urban planning, these kinds of things. And I think that's ultimately what we want to do is make lives better.
Question here.
Okay, Jeff, I'm from Loyang, China. I have two questions for you. And first is, what's your opinions on Geoffrey Hinton's opinion about backpropagation and his work on capture? And then the second is there any plan that Google will build a TensorFlow community in China, just like an Android developed community? Thank you.
Mm-hmm. Sure. You know, I think, you know, Jeff's opinions about backpropagation change year to year. You know, he's obviously a brilliant scientist, and the capsules work I think is really interesting. It's sort of really, it's essentially looking for patterns of agreement at the lower levels with a sort of iterative algorithm before it progresses on to the next algorithm, rather than just sort of blindly propagating up information. He's been trying sort of a lot of variations of this approach for the last couple of years, and I think he's really hit on one that seems to be working well on small problems. And so I think the next steps for that are, you know, what does it actually do as we work on bigger problems? You know, I think the TensorFlow community in China is reasonably vibrant, and I think we want to do things to encourage it to be even more vibrant. So we don't have anything to announce, but that definitely seems like an area we want to work in. We're going to do things there. Okay.
Okay, great. Quick question from Korea. Lily, why did you focus on diabetic retinopathy and breast cancer? Any other disease research plans in the future? What's next?
Yes, so we started off with diabetic eye disease simply because that was, you know, the initial problem that our partners in India came to us with. We didn't have a research group in healthcare at that point, and so that was a pretty pressing need for them, and it was clear that we could help. It was a project that we started off based on that need. And as we were looking at places where you know, the variability in reading can actually have a high impact. That's where sort of the pathology project came along, and you can imagine that this technology works really well for all sorts of types of medical imaging. And so, you know, we're looking at other places where we think that this can really make a difference.
Great, cool. Thank you very much. I think there's a question up here.
Hi, Shruti from India. I wanted to ask about biases when it comes to training your AI models, and how easy or how difficult is it to weed those out, because something that you might not consider as a bias could be, it could, you know, work the other way in a different culture. For instance, recently I think Apple has reported that it was storing some photos in a bra folder. And I thought that was pretty strange that somebody is training a computer model to actually recognize a bra, whereas there's no particular folder, say, for shorts or something like that. And in fact, I think even Google's photos can actually identify bras, which I thought is again odd. I get it that it needs to learn shirts, but the fact that it's identifying something, which as a woman I found that strange. So again, how do you keep our biases, and especially if you're moving on to automated machine learning models, which means the bias is already there, how are you going to beat that out if that's the future that you're getting?
Yeah, I mean, I think this is obviously a key problem as we start to have more of these models used for lots of different things. One of the key ways you can eliminate bias is to make sure that the data that you're training on is actually representative of the data that you're testing on when you're actually using it in a product. For example, you don't want to collect all your data only in the US and then use that model in India and Pakistan and other places. You want your data to be representative of the different sort of customs or local standards that exist. I think that's one way. The other way is you don't want to necessarily rob these models of all bias. Essentially, they are part of their power is detecting correlations and biases in the data that they see in order to actually make the useful predictions that they do. So when I see correlations of like whiskers and ears and things like that, and that tells me it's a cat, that's actually a good thing. If I train a language model to say that the word cancer and biopsy are related in some way, that's useful. But if I see that the word doctor is associated with he and nurse is associated with she, that's perhaps a bias that I don't want in the model. But that is the bias that it learns from real-world training data of text in the world. And so we're doing a lot of work on sort of algorithmic ways of removing biases that we don't want in the sort of machine learning models, but while retaining the biases of things like biopsy and cancer are related, because that's actually part of the power of these techniques. It's a tricky problem, and that's essentially a research problem and a problem that faces anyone trying to deploy machine learning models.
Okay, I've got a question at the back here.
Hi there, Peter Wells from the Financial Times. First of all, thank you very much, all of you, for sharing your views and opinions today. Thanks, much appreciated. Question maybe for Jeff. A couple of months ago, Eric Schmidt had been talking about a race of sorts between China and the US in terms of artificial intelligence. And I think he suggested that perhaps it was only going to take 5 years before China might overtake the US in that respect. Just interested to see how you see that race playing out. And then, I guess further to that sort of main question, what sort of things the US could do if we were going to look at this from a US perspective? What sort of things the US would need to do or could do in order to maintain its lead or be in the lead? And then finally, what role do you see Google playing with that in terms of competition for hiring engineering talent? I think recently you guys opened up an engineering office in China. And I think that sort of comes with a suggestion amongst the media community or what have you that you could be drawing talent from Chinese operators equally. You are just a magnet really for that sort of thing. So I'm just interested on how you see that race playing out.
Obviously, I think there's lots and lots of entities interested in machine learning and AI around the world. There's many companies are interested in it. Many governments are sort of very aware of the potential for it to solve lots of problems in their societies and are at various stages in how proactive they are about investing and funding basic research and encouraging the ecosystem. I saw the report that the Chinese central government put out about AI, and that it seems like a pretty well formulated plan. The US government, I think, is not quite as organized in that respect, but also we tend to have a lot of our research happening in corporations and academia, which is a little bit more chaotic ecosystem than a more sort of central plan. But I think all of these things are useful, and it's clear that machine learning and AI have a lot of potential to affect not just computer science, but many industries. And so I think that's why you see governments and companies investing heavily in it. And part of that is trying to hire really good people who have these kinds of skills who are not that prevalent in the world at the moment. And that's obviously creating competition. There are lots of solutions to this. One is training more people with these kinds of skills. I think there's tons of interest in academic communities in entry-level machine learning courses. They're always oversubscribed by factors of 3 or whatever. So over time, I think more and more people will get these skills and they'll apply these skills to more and more interesting problems.
What does Google need to do to maintain its edge in this whole?
Well, I think we want to focus on the next frontier of research problems and hire the best people to equip them with kind of the best kinds of computing hardware for these kinds of problems, and work on solving interesting and real problems, and not worry too much about what our competitors are doing, but focus on the research.
Okay, great. And it's worth reinforcing that we've had an engineering office in China.
Yeah. This is, I think there's a renewed emphasis in hiring machine learning people, but we've had an engineering office in both Shanghai and Beijing for a while.
Yeah, exactly. Question over here.
Hi, I'm Masahiro Nakagawa from Japanese business magazine Tonkei. I have a question to Jeff. So about auto ML. So did that change the way you see in the future of machine learning? I would say like short term, 5 to 10 years. Like how do you think accelerate the development of machine learning?
Right. I mean, I think this might relate a little bit to your question about how do we go from these narrow machine learning systems to ones that can sort of flexibly deal with more problems. And I think we obviously are starting to use this internally for a lot of our problems, where we actually have data sets where we can point AutoML at it and get better results than our ML researchers and engineers have been able to get on particular problems. So that's starting to have an impact within Google. We also want to bring this technology to external organizations as well, because we think there's a lot of people who have machine learning problems and have the expertise to kind of collect the right data and to maybe label the data for a supervised learning problem, but maybe don't have as much skill in how do you actually create a machine learning model. We think these kinds of approaches can, perhaps broaden the use of machine learning to much wider sets of developers and others around the world. So I think this won't be a 10-year thing. This might be a relatively short-term thing where it's starting to have impact in the world.
Okay. One more question from China. Isaac, probably for you. When did the development of pixel visual cores start? Beside HDR+, what else will be applied in the future, and how can developers make the most of it? There you go.
So we've been working on.
Still not on.
Please switch on. We've been working on Pixel Visual Core for several years. It takes a lot of time to bring up an entire chipset, tool chain, get the drivers running, finally shipping the product with the algorithm running on top of it. So HDR+, which is our low light and dynamic range algorithm that we use in virtually all the photos that you take with default camera Pixel. Through Pixel Visual Core, we'll be able to bring HDR+ to third-party apps as well as the default camera apps. So that's a huge advancement for image quality across all the apps that use camera on your Pixel phone. In terms of things we intend to run on top of Visual Core in the future, I don't really have anything to announce just yet, but like Jeff mentioned, it's a kind of core that's suitable for a lot of general kinds of workflows, things like imaging workflows, things like machine learning. So there will be more things over time, more and more things, but nothing specific right now. And I also don't work exactly on the Visual Core team, so I don't know what kind of tools and developers are looking up. I'm sure we can get an answer.
Okay, great, cool. We're standing between journalists and lunch, so let's take 2 more questions. I've got 2 here. Yeah, please. And the lights going off earlier was the AI system saying don't ask long questions.
Okay, I'm Sriram from India. I'll keep it short. So we've heard about the good things that AI is doing for us, but it's also going to cause possibly problems such as job losses, like automation is already replacing jobs and so forth. So where does the responsibility lie with governments or with companies like Google in addressing these issues? And specifically, and this is the larger question about bias, to handle issues such as bias and other problems. Do you have an ethics committee at Google to initiate policy discussions with government? What are you specifically doing to address the problems that technology will create?
Sure. I mean, I think that's one. Is that still in? Hello? Which?
Take them all.
I'm going to try this one because this one worked before. Okay. So, I mean, I think the issues of machine learning and AI being able to automate some aspects of work is not a new thing. Like, this has happened with technology for the last 200 years. I do think here will be, what you'll see is that it may be able to automate things that we didn't consider automatable into, 10 years ago. And so I think this is a general societal problem. Governments need to be thinking carefully about what their policies should be for people who are, affected by this. But ultimately, I think every time technology has displaced, what was previously human labor, I think we've gone on to create new and interesting professions as a result of, on top of this technology, right? And I think that's clearly going to happen here as well. We'll have entirely new kinds of jobs that we don't even think of today. Who would have thought about, social media consultants before the web existed, right? And so I don't actually know what those jobs will be, but there will be new kinds of things that once machine learning can automate some of the things that are more repetitive and simplistic, will actually enable people to accomplish more and to do more in conjunction with technology than individually. And for bias, I think we do have a responsibility here because we're sort of deploying machine learning systems and seeing that these AI systems do have bias, and we're actually doing fundamental research on this. I hope every machine learning organization in the world is looking at these kinds of issues. That one seems less like a governmental issue and more like a AI research issue.
Okay, great. One last question.
Hi, Ashish from CNET. So I guess AI in general is a lot more accurate than a human based on discourse. Are we ever approaching perfection? And I mean, in the case of in medicine as well, when you diagnose biopsies and even the blindness thing, how do you ensure that your accuracy is there? And what happens when it's misdiagnosed and it actually affects the patient in that sense? And then one more question is the moral problem of the trolley problem, where you hit 5 people or you save 1 person. What happens when what do you teach the AI?
So I think in the context of medicine, I'll take that question in the context of medicine. I think, we've noticed that the machine learning models that we built are really good at predicting whatever label you give it, right? So if you give it what a human being said for a skin, based on a skin lesion, it will, model it'll give out what your doctor at some point said. Now, we also know in medicine, whenever we look at these kind of things, there's a battleground truth than just human interpretation. There's biopsies, right? And there's additional tests that we do. And then also there's a longitudinal aspect of how the patient turns out in the future. And so those are better sources of ground truth. And if you can get that type of label, you're going to get a better read on how the patient will actually do, and that's exactly what we do when we're reading when we're reading these images. We're actually projecting what we think will happen to the patient. And so again, I think this is a point where we can actually use AI to even do better than what we have right now, to push the limits of medicine and really contribute to clinical research in that way. So that's actually really great. I don't know if we'll get to perfection because there's always this, some uncertainty about how the patient will turn out. So even if you got really great data about what happened to the patient, I think there will still be some uncertainty that you can't account for in these systems.
The trolley problem, I think that's a bit of a false problem. It's not like anyone is in there writing code saying, if I go right 3 people, if I go left 2 people, right? It's much more like a human driver, right? You're trying your best to, not have any accidents. And I actually think, autonomous cars, which I think is the context you're asking this question in, have a tremendous number of advantages relative to human drivers. They don't get distracted, they're not going to be texting, they can see in all directions at all times. So I think, there undoubtedly will be problems as these technologies are deployed, but I think they will actually end up being much safer than human drivers, and they don't have code in there that is making these sort of explicit decisions. They're essentially trying to be safe at all times, and I think they will actually end up being safer.
Fantastic. All right, thank you all for your questions, and I want to thank our speakers who've joined us here today. The lunch is through the room that way, so if you go through that door, and there is a photo wall, there's going to be a quick opportunity to get some photos of some of the speakers as well, as you file your stories.
Okay.
So we're going to head through this way. Thank you very much. Oh, no. Only the speakers that way, everyone else this way. There